A very good morning and a warm welcome to everyone. And thank you for taking the time out of your schedules to join us for this fourth webinar in the Simune webinar series on cybersecurity. To give you a quick glimpse into Simune is Locus's venture into cybersecurity. We focus on key technologies like MDR, Zero Trust, Security Operations or SecOps, IDAM, database and application security, cloud security, and more. In the last webinar, some of you had inquired about our relationship with Palo Alto and shown interest in learning more on what we have to offer in partnership with them. So here we are, and glad to have our partners from Palo Alto join us for this webinar today and be our guest speaker. For years, Locus and Simune have been successful partners to Palo Alto. We have to our merit several Palo Alto next generation firewalls and panorama deployments. We are certified and well poised to offer Palo Alto next generation firewall, Cortex XDR, Cortex Data Lake, SOAR, Prisma Access, and Prisma Cloud. With that, let me introduce Mr. Arinjay Wade, our speaker for today. Arinjay is a cybersecurity solution architect at Palo Alto Networks with over a decade of experience. His specialities include networking, cybersecurity, endpoint, and cloud security, to name a few. Arinjay, towards the end of his presentation, will be giving us a live demo on an actual ransomware attack. And that should be reason enough, I'm sure, for all of you to be glued till the end of the webinar. Without much ado, let me just go over some of the webinar hygiene protocols that I would want each of our participants to follow. Let's keep ourselves on mute at all times for better audio clarity. You may please ping any questions you may have at the chat window. We'll be taking questions at the end of the presentation and the live demo so that we do not interrupt the flow of the presenter. With that, over to you, Arinjay.
Thank you, Runa, and good morning, everyone. I'll just quickly share my screen. Runa, can you see my screen?
Yes, Arinjay. Good to go.
All right. So yeah. So hi, everyone. My name is Arinjay Wade, based out of Mumbai, associated with with Palo Alto Networks since last 4.5 years. I'm a cybersecurity solution architect, working on commercial, banking, manufacturing, media customers in last 4 years. So just a quick overview on today's agenda. What we'll see is just to really look at what exactly is happening in today's world in terms of threats, how threats are emerging, what are the different kind of attack life cycle that we call, is how does really attack happens, what are the different stages in attack, and then what is the best approach to prevent more sophisticated attacks. Again, the focus here is not on the commodity kind of an attacks, but how can we really prevent a successful cyber attacks that really goes through different organizations, right? And then map it with the Cortex XDR solution, with the deep dive on the technology and certain use cases walkthrough. At the end of the session, I'll be giving you a short demo on actual ransomware attack, which was very, very popular, which is now shut down, but it was the most destructive ransomware attack at that time carried out by a Russian group. And then we'll also take a question and answer, right? So without further ado, let's get started. So, what kind of different attacks today, what we see? There are certain known threats, invasive malwares, zero-day attacks. I'm sorry, is there a question or something?
No, you're good.
Someone is talking.
Yeah, I've just been trying to mute them.
Yeah, so to prevent successful cyber attacks, we must first look at, how do they occur and what are the different things, what different kind of attacks that we see. Organizations today receive, a continual baggage of attacks. These attacks range from simple known attacks, where threat actors simply reuse the existing malwares and exploits. They may send out an email attachments with common ransomware or cryptocurrency mining malwares and hope to compromise and, and unpatch systems. Or threat actors might take known exploits or attack methods and attempt to hide them using some evasive techniques like restructuring the file, or maybe encrypting the file into encrypt and send it to an encrypted channel, or running a malware in the memory itself. We sometimes call this as a fileless attack, right? And if those attackers are really well resourced, which they are, and they are following a lot of automation today, a lot of collaboration, which we are not doing, they might develop a zero-day attack that takes advantage of unknown applications or system vulnerabilities. The good news is that the right prevention tools can stop these over around 90 to 99% of the attacks automatically, right? That's a good news for today. They can apply multiple analysis engines from the reputation of the source and the signer of the file to the bytecode distribution functions in an executable. Since many zero-day attacks use these known techniques like buffer overflow to execute, the right security tools can stop these zero-day attacks, or maybe some known and unknown attacks to certain level, even if they have never seen before. But that's one or two odd techniques that can be stopped. However, the most sophisticated attacks and potentially damaging attacks require a detection and response over a period of time. Now, these attacks, such an and can it can be an insider threat or targeted and a low and slow nation-state attack. So, WannaCry example, PETA as an example. We have seen a lot of data breaches which got published recently, right? So, even some advanced fileless attacks that look like a legitimate scripts may require manual verification from a security analyst. Oftentimes, the only way to identify these attacks is by analyzing activity over a period of time. It cannot be found out or cannot be identified just by looking at one particular thing, or one particular suspicious activity. And across, so what it requires is analyzing activity over time and across the different data sources with machine learning. These, and not by doing a manual correlation or by manual identification. These advanced attacks rarely can be identified in real time or with only one source of data. And oftentimes, a security analyst must try to understand the intent of the activity to determine whether it is an malicious activity, or it is a ransomware attack, or it is a data stealing activity. And hence, while these attacks constitute less than 1% of the attack that you will receive, it can be extremely destructive and dangerous. And we think you really need to have a set of right tools to detect, investigate, and stop. So before we really look into the solution to prevent these successful cyber attacks and sophisticated cyber attacks, we must really need to first look at how do they occur. Unless we don't understand how does the attack life cycle or how does the attack different stages are, we cannot really design or develop a solution or maybe identify a right set of tools that is required to stop them. So while not all the attacks follow the same steps, most of the attacks begin with the vulnerability exploit and malware installation, right? So vulnerability exploit is nothing but understanding what kind of applications are running in the organization, whether the users' machines are patched or not, whether they are running any unpatched or maybe old Microsoft Office applications or Adobe applications and so on. Once they do that, attacker needs to sustain the repeated access to the compromised system through a command and control, map the subnet, map the different network, find and explore other segments that they want to move laterally until they find out and steal a valuable data, or carry out a ransomware attack and so on, right? Or maybe deface the web property or something like that. If you look at these steps, the initial exploit and malware installation occurs very, very rapidly, right? It may involve a single file or a request, or often can be identified by simple indicators of compromises like a signature or a hash file or an IP address, something like that. So by analyzing a packet or a file, a security system can really determine this attack very quickly. The later stages of the attack are different. They often occur that often in seconds, but in days or weeks or months. They involve a large number of network actions, oftentimes individual movements, such as attacker moving laterally, cannot be identified with traditional indicators of compromises. To limit the opportunity for an attack to succeed, organizations must disrupt every step of the attack. So if we are able to identify each and every step at the right time, we will be able to more or less successful in terms of identifying and protecting this kind of an attack, right? And then attackers really has to do this is just one of the example that how attackers really starts from vulnerability exploiting to malware installation, command and control, lateral movement, and data exfiltration. Now the latest one or two or three stages of this really has got different kind of things. If you can see on the screen, there are repeated number of repeated access to unusual site that we have never seen before. An endpoint which is connected to a site which we have never seen before, or it is trying to do trying to access certain database servers, trying to do a trace route, or trying to understand what kind of different applications are hosted in the DMZ. These kind of things sometimes it cannot be identified just by having a signature or by hash. It really requires a lot of behavioral detection, really requires a lot of profiling of the user so that we can identify that what exactly is happening inside the network and how the attack is being carried out, right? So in order to really look at this and in order to get the proper visibility and control these kind of various suspicious activities, there are tools available today. There is a threat intelligence coming from different solutions. There is EDR, which is called as endpoint detection and response, which only focuses on the endpoint. Integration with Active Directory logs, events, network traffic analysis, where these solutions really focus on data which is related to network, where it is connected to unknown domains or some domains which are hosted in Canada or China, Vietnam, or maybe some of the domains which are really newly published domain names. Those domain names called as domain generation algorithms sometimes only be there for 15 minutes or a week, and then they just go off, right? And then one of the main critical component is UEBA, which is user behavior analytics solution, where somebody is really profiling the user, the behavior it is doing, and then trying to correlate and then trying to see. So what these tools and solution generally does is create a lot of logs, tons of alerts, instead of effectively stopping these attacks. And all these different solutions really works in a very siloed and isolated manner, where SOC analyst or a security administrator really need to look into each and every event, make sense of it, correlate it, stitch it together, and that's really a lot of manual requests, a lot of manual response it consists of, right? So typically in the legacy approach that we have seen, which is really increasingly complex nowadays, is a solution where we have SIM, where it has got its own data lake, collects logs from different sources that we saw in the previous slides, alerts different threat intels, and then it prioritizes the alerts depending on the intelligence that it has. Then we have EDR solution, simple. It's a simple to identify, only on the endpoint focus, separate dashboard, separate data, separate threat intent, separate correlation, connect to the SOC or ingest that data into in a SIM and leave it to the SIM people or SOC analyst to correlate that, right? Third resource may be an NTA, where we have another dashboard, different kind of an AI and machine learning, different context, different threat intel, different reports. Again, data is ingested to the SIM and then leave it to the SOC analyst to really make sense of this data by stitching it all together. While what we are looking at is one data lake, where you get data coming from all the different sources like endpoint, cloud, and network, stitch it together, normalize the data, make some sense out of it automatically with the AI and machine learning, and then send it to the SIM in order to, and then the SOC analyst can really make sense of it, because a lot of automation, a lot of automatic correlation and log stitching is already done by the Cortex data lake, right? So that's what we are trying. So today's response really has got a wrong data. Why I'm calling the wrong data is because the data is only coming from a specific source. EDR only look at the endpoint data. Network traffic analysis solution only look at the network data. And hence there is inconsistent logs, mostly violations, and collecting right data requires deploying sensors and agents at each and every points, where today is coming from different vendors, different solutions, right? And because of there's a lack of scale, everyone has a different database, everyone has a different correlation engine, everyone has a different way of automation, right? So there is a lack of scale in terms of really how we can correlate all this data together. And because of there is all these things are siloed and all and works in different, the rules that is defined are typically manually defined correlation rules. So there can be a rule, you can see that a rule for identifying a false positive, that rule may be applicable only for an EDR solution. You need to write a separate rule for network traffic analysis. You need to write a separate rule for UEBA type of solution. You need to write a separate rules for identifying an indicator of compromises. So these are all manually driven static investigation, which really slows down the investigation. What is required today is really a rich amount of data. What I mean by rich amount of data, and which I'll talk about in detail in the next coming slides, is the data has to be very, very comprehensive. It should come from the network, endpoint, cloud, and collected by existing infrastructure, and then stitch it together. And then and then that should use and leverage a cloud scale and agility. So it should not be an on-prem where we have 5 terabytes of data, and then we run out of that storage because we collect a lot of data from the endpoints or from the network, and then it doesn't make any sense at all. So we leverage a lot of cloud scale and agility where we can really utilize and leverage the data coming from different sources and rapidly innovate based on them. And instead of giving a static rule, let the machine learning do its job by completely automatically profiling the behavior, understanding what's happening inside the network, make sense of network and endpoint and cloud related data, and then really give you a very rapid response, which are, rather than generating thousands and thousands of alerts, we give a very small number of alerts which are extremely actionable, and those are already correlated with backend with the threat intelligence and an endpoint analysis and also a network analysis, right? So that's what is really required today. So how do and this is one specific point which I always discuss with all the customers. Today, EDR is something which is definitely all majority of customers looking at. But if you really look at the EDR, visibility is only limited to the endpoint. XDR really gives you an visibility. The Cortex XDR, why we call this the XDR? It's completely cross-platform. There is no dependency on the endpoint or only on the network or only on the users, right? XDR gives you visibility across all the user, network, and cloud layers. Traditional EDR focus only on the endpoint data, and that gives you a very limited visibility into which leads into misdetections. Maybe you might find some malicious or suspicious activity happening on the endpoint, but what if there is no activity on the endpoint and somebody is really trying to steal the data out by just using a very genuine tools, like ping, traceroute, netstat, etc. So there can be a good amount of misdetection, increased false positives, and longer investigation time, right? And it generates a lot of events that we saw in the next in the previous slides. And one of the very key components that when I ask this question to a customer, that when you identify something on the endpoint, and if there are certain more indicators of compromises, certain more artifacts which are related to that particular attack or a malicious activity, like maybe that file or that particular script is communicating to a malicious or a suspicious IP address or a URL or a domain name, what is the next action that you do? It says, because we only have a data from endpoint, we see that IP address sometimes on the endpoint, sometimes we don't see that. Then we correlate that. We use our network team in order to see logs and analyze the logs on the firewall or on the proxies, and then try to see, really correlate with the help of time that whether this activity happened at the same time when the attack happened on the endpoint or not. And then again, dependency on the network team really increases, because the first thing that they really wish to do, and I ask this question to customer, when you see an IP address, when you see an IOC or a URL domain name associated with that particular malicious file or script or an attack on the endpoint, what is the first thing that comes to your mind? 99.9% customers say that the first thing that we do, apart from isolating the endpoint, we need to block that IP address on the perimeter level, because we don't want to spread that attack to another systems in the network. We don't want to laterally move that attack from one system to another system. So first thing that we do is block that IP address or block that domain or a URL, and that increases a lot of dependency on the network team, a lot of correlation. And before we reach to that conclusion of blocking that IP address, first it really needs to make sense of it. We need to understand, hey, this is the IP address which is associated with that, because that user, that machine, or that application may be communicating into a lot of other IP addresses. We don't want a business to impact. So we need to be extremely careful that IP address or a URL is associated with attack only. That takes a lot of time. It may take half an hour, it may take 24 hours, it may take weeks at times, depending on the kind of attacks. So that's an EDR and dependency on EDR. But what we are talking about XDR is really no dependency on network teams. It really has got 4 main pillars: network, endpoint, cloud, and third-party data. So the main fundamental, the main in the architecture of Cortex XDR solution is the Cortex data lake, which is a very integral part of the solution, where we take data coming from network like Palo Alto Networks firewalls. One of many of our existing network firewalls users is really seeing a lot of value of this, that they can really leverage the data coming from our firewalls. We take the data coming from endpoints. We take the data coming from users who are working from home with our global protect solution, right? We take the data coming from virtual firewalls and Prisma Access, Prisma Cloud solutions coming from the cloud like AWS, Azure, and Google and Alibaba. And then we are recently started around 7 to 8 months ago. We have also started ingesting data coming from third parties. Now, these third parties can be Fortinet, it can be Checkpoint, it can be Cisco, or it can be any third-party network firewalls data which can give us the data in the standard syslog format. So here is the entire thing, and then we take this data into a data lake, normalize that, stitch it together, and give it to the Cortex XDR in order to make sense of it. So XDR has got this inbuilt analytics engine, inbuilt machine learning, and continuously keep on really looking at the different behavioral data. And mind here is that I'm not only talking about a hash lookup. I'm not talking about only an IP address lookup. I'm talking about the entire set of behavior. I'll give you a very small example which I recently come up with during one of the POC, that a user who was doing an activity that I feel that that endpoint was compromised, and then that some of the activity happened when the user was in the office, right? And then when that user actually went to home and could not come back, that user was coming from a Global Protect Prisma Access cloud delivered service for accessing certain applications in the cloud and also in the data center. So remaining part of the activity, which was really so the compromise in the endpoint happened when the endpoint was actually in the network, but the data stealing, the data exfiltration started happening when the user actually went out of the office and then it connected. So what Cortex Data Lake and Cortex XDR really did is really stitch that log when we got those logs coming from the endpoint, when the endpoint was in the office behind the Palo Alto Networks firewall, and when the endpoint came to went back to home and tried to do some activity unknowingly, unintentionally, that log coming from the Prisma Access solution, which is cloud delivered solution, Cortex XDR stitched that log together with the endpoint and really, gave a nice proper step-by-step action view that this is how the attack happened. This is how the attack started when the user was in the office, and a later stage of the attack happened when the user actually went back to home. And that's exactly the point here, is that we cannot just depend on the endpoint data. We need to have a network data, endpoint data, cloud, and third-party data as well, right? So what all things that we correlate? We correlate network, threat intel, user host, applications, extremely important part, because layer 7 applications is one of the main threat vectors which is used by attackers to come in, and the endpoint. We continuously keep on collecting this rich amount of data for behavior analytics and artificial intelligence, and then automatically correlate the data to gain a context of the investigation. And this context really lead us not by generating an alert, but actually give you an incident, which I'll be showing you in the demonstration as well, right? So this is a piece of information that we collect. We collect TCP port, countries, destination IP, number of sent and received bytes. These really can help us to understand whether there is a large upload happening that we have never seen before, and we use that data in order stitch it together with the user behavior also by taking username, host name, which organization unit it belongs to, what is the MAC address, what operating system it uses, what is the threat intelligence, are there any malware hashes, malicious IPs, phishing URLs, URL categories. One of the very important part, what I just spoke about, is application name, different protocols, what is the response size and response code, different URL domains, context, etc. And then we collect also a very rich endpoint data where there is a file update, any registry changes, any changes in terms of hashes, MD5 hash, file path, different kind of CLI arguments, and then all these things is automatically collected from the network, from the endpoint, from the cloud, and then stitch it together in order to make sense of it, right? So what is Cortex XDR? Cortex XDR gives you a full endpoint protection with our EPP modules. It gives you a full user behavior analytics. It gives you a complete network traffic analysis and complete EDR, right? So with Cortex XDR, we are redefining the security operations by breaking down product silos like NTA, user behavior analytics, and endpoint detection and response solutions. These silo detections and response tools require their own storage, as we saw in the previous slides. Many of them may require separate sensors like network data collectors for network traffic analysis, endpoint collectors for endpoint traffic analysis, etc., endpoint data analysis, right? With Cortex XDR, we leverage a single existing security infrastructure to collect the data. Now, mind it here, when I talk about network data, we can also leverage third-party data, as we saw in the last slide. So it does not really depend that customers Like you should have only Palo Alto Networks firewall. You can also have a Fortinet firewall or checkpoint firewall. We totally understand that. You might have two vendor policy where you have one Palo Alto firewall and other is a completely from a different vendor. So with this, we leverage existing security infrastructure as well to collect the data, and we natively integrate with network, endpoint, and cloud data to detect all the threats and provide more context for investigation. We are also breaking down the barriers between the customer's detection tools and all the prevention tools by tightly integrating data connection, analysis, and enforcement. So that means the enforcement is also very, very correlated, and by making sure all your security works together to share threat intelligence and update defenses, right? So that's the real value of Cortex XDR solution, where you get entire everything in one single agent and one single application-based solution, breaking down all the data and product silos, right? We also understand there can be an use cases where Cortex XDR agents are not directly connected to the network or internet since it's the cloud delivered service. Then we have a broker service where Cortex XDR agents communicate to the broker service. Many times I've seen this in an air gap environments or maybe certain IoT or SCADA environments where users are not directly allowed to communicate to the cloud or communicate outside the organizations, where we can leverage broker service where users are not exposed to the internet, not exposed to the outside world, but still get the entire value that we talked about from the Cortex data lake and Cortex XDR application through a broker service, right? So we can also protect the users, endpoints, servers which are online and offline as well. And this is many of the EDR solutions that we have seen really must connect to the application which are hosted on the cloud, right? So that's like a gap in the security solution. What about the users who are not connected to the cloud solutions directly? So we can leverage a broker service there. Let's look at some of the very key focused endpoints here, use cases here, where how do we really prevent threats with traps, which is now rebranded as a Cortex endpoint protection, where when user attempts to execute and run the executable file or maybe an office file or any file, we prevent all the known malwares with the help of wildfire threat intelligence, which comes inbuilt and integrated with the Cortex XDR solution. So whatever we know, we just stop it directly there, right? Whatever is the new malwares, we use a lot of machine learning. So wildfire keep on analyzing millions and billions of sample every week, and we bring that analysis intelligence, we bring that algorithms whenever we see something new to directly an agent by also doing a local analysis on the endpoints. So in case if the client is not connected, we also do a local analysis on the endpoint, and a lot of machine learning is directly there on the endpoint. Then we also really try to do a behavioral threat protection and I'll show an example of that how does that particular attacker or how does that particular malicious activity is behaving. I'll give you a small example where if there is a Word document which is attached to that email and somebody really execute that Word document, whether it is really only a Word document or it is silently opening a PowerShell and trying to run a script. And that's a behavior, that's a suspicious behavior. Why would a Word document open a PowerShell script or maybe certain other commands that I'll also talk about in the next slides, right? And then whatever is unknown, we also leverage wildfire in order to send that samples to the wildfire cloud and get additional information in future, right? So whenever the attack is executed, we really stop that attack. And there are two ways of stopping the attack. One is a signature-based solution, which is a legacy approach that we have seen. Traditional antiviruses and all the next generation antiviruses have a lot of signatures. So Cortex XDR is a completely signatureless solution. Rather than looking at the signature or try to match it with the hash of the file, we really try to understand whether there is a zero-day exploit or not. I'll give you a small example. This example says that there is a PDF application and where we see a lot of patches every day, right? Which has got these small gaps in the circle, shows you that there are vulnerabilities. And these vulnerabilities keep on coming. Every application, every operating system that we use, whether it is Windows, Mac, Linux, whether it is a PDF application, Microsoft Office application, Chrome browser, Mozilla browser, IE, etc., all will have some of the other vulnerabilities. And what generally these vendors do is when we see a vulnerability, they analyze that vulnerability, do a research on that, try to patch it, and then they release a patch signature. And that's what we as an antivirus or IPS host, IPS solutions really consume that as a part, in the form of signature, right? So whenever there is a vulnerability, there is a signature available. Whenever there is a malicious file, there is a signature available, which is really triggered when the hash is matched, right? What we are doing, rather than depending on the vulnerabilities which is being exploited, which is being used by exploit techniques which are very, very limited, we focus on those techniques. So it's like rather than preventing and protecting myself against the bullets which are being fired to me, why not destroy the tool or understand the tool which is really firing those bullets? It can be a pistol, it can be a rifle, it can be a machine gun, whatever it is, right? If I try to destroy that tool, I really don't need to worry about the bullets, and that's what I'm talking about. So when there are different vulnerabilities or bugs, vendor really patches those, and that's how you get protected. What there is a new vulnerability which are never seen before, or I will give you one more example. Attackers always knows that there can be a solution for one or the other vulnerabilities or exploit, and that's the reason why they always use two, or maybe one of the very very advanced attackers uses uh, combination of two or three different techniques. So if vendor really has patched one of the technique, one of the exploitation technique or vulnerabilities, uh, attackers very well know that there can be a third one which can help us to go through, and that's what we are talking about. We don't really talk about vulnerability patching. It's a complete exploit prevention. So there is more than 20 odd exploitation techniques available today, and we are the one we cover the maximum exploitation techniques today in order to give you prevent against the most dangerous and destructive successful cyber attacks right at the first stage itself, right? And then whether the attacker is using one, two, or maybe combination of three different techniques, it doesn't matter, because all the techniques are blocked, all and not actually the vulnerabilities, right? So we don't patch. And then we also carefully have mapped that recently with the micro attack tactics, which really focuses on a lot of different stages of attack cycle that we saw, right from the execution, persistent, discovery, lateral movement, command and control to the exfiltration level. So I will also show that in the demo, that how we have mapped that in the demo as well. So when there is a non-contextual data, typically this is an example which I have tried to capture, is an antivirus. So there is a Tesla script ransomware which I'll be using in the demonstration as, is that if you execute, if you have the hash value, if you have the signature, this is what is the alert that you will get. If you do not have, then this will pass through, and then vendor will release a signature or a patching, and then only we will be able to catch. But this is not a contextual data. Why? I mean, is this the only thing which has happened to carry out this attack, or there are certain other steps as well? So when I talk about contextual data, I really talk about how we can give a causality view. Causality view is nothing but really stitching the data together from network, endpoint, and cloud, and give you a proper chain of events, how that attack has happened, what are the different activities done, what is the meaning of those activities, step by step, and how the attack has happened over a period of time. And I'll be showing this example. So when about threat prevention, the local analysis, dynamic analysis, a lot of things coming from wildfire, on-prem, online, offline, ransomware prevention, behavioral threat prevention, technique-based prevention. So we really use a multi-method prevention, which is a very, very balancing. You cannot only have an offline threat prevention or endpoint prevention or completely online. You really need to make a really good balance of online as well as offline use and leveraging of different techniques and solution, and that's really help us to really prevent most successful attacks, and also able to really reduce the false positive. If you really depend on the offline solutions only on the local analysis, you can expect a lot of false positives there, and that really over a period of time really create a nightmare for SOC analyst or security administrator. So what Cortex XDR gives you is a proper balance between an online cloud-based machine learning solution as well as an offline local analysis and ransomware prevention with the help of behavior threat detection, recurrence protection, and a lot of exploit technique prevention that we saw, right? So when we look at the best-in-class endpoint protection, this is what we do. Before somebody, a phishing email is received to an user, or maybe credentials are stolen, that are used to log into RPC and download additional malwares, then exploit those local vulnerabilities which are there on the endpoint machine, infect the local endpoint and prepare for the exfiltration, and then do a lateral movement from one machine to another machine in order to spread the attack or widen the the attack surface area. But now with the Cortex XDR on the right hand side, what you see that we can stop that attack at right from the exploitation, so right from the first level to the last level, where we can cover the entire attack lifecycle and keep stopping that attack at every stage. That's really give you a maximum coverage in terms of endpoint prevention. And now there will be still some attacks which are absolutely not using, and I give you an example of that data exfiltration example which I give in the beginning, that still requires some advanced threat detection and response, right? So I'll give you a very small example of this. At 10 o'clock in the morning or maybe in the night, there is a process which is process A, which has created a file in the system 32 folder. Immediately after that, the process A spin up another process called as process B. In the technology world, we call this as the child process, which actually used to set a registry key inside the registry of inside the Windows registry. And then that created additional process, which actually created one more child process, which actually leveraging a PowerShell, which is used to establish a network connection to some IP like A.B.C.D on a 8080 TCP port, and then actually change. Once that is done, it actually change the property to hidden. Now this really changing a registry is a valid technique. Creating a process in the system 32, valid technique. Opening a PowerShell, valid technique. Connecting to some IP address over a port of TCP 8080 is completely. If you look at these chain of events in a very, very isolation manner, all these things looks very, very genuine. And not everything will be collected on the endpoints. The network connection going to some IP address and the port will be seen on the network firewalls or maybe on the proxy, right? The process is created on the endpoint. The file is created on the storage on the endpoints. So if you want to make sense of this data happening over a period of time from 10 o'clock 10 to 10:07, lot of different process, lot of different file activity, lot of registry activity, lot of network activity. So there is a lot of activity done. So by using our BTP inbuilt module, which is called as behavioral threat protection, we carefully analyze each and every action, each and every series of events, each and every file being executed or written, the property of file changed to hidden, what is the registry, and really make sense, make sense of it. And that's why we are able to prevent sophisticated attacks that leverage built-in OS executables and common administration utility by continuously monitoring the endpoint activity and the network activity. Okay, and we do it not only for a set of endpoints, we do it Windows, Mac, Linux, all different kind of endpoints, right? So when we talk about identification of these behavioral threat analysis, just to do a step back, there are IOCs and BIOCs which are related to that. IOC will give you one single activity understanding. It really says that, hey, this hash is bad, this IP address is bad, this file name is bad, right? That gives you IOC. That's done by Cortex, that's done by all the other vendors. But on the left hand side, what you see is a behavior. It really try to detect different kind of behaviors, whether writing the files, creating a different process, open network ports, or change the registry key, etc., etc. And this is one of the very, very main differentiators. And another differentiator that you can create your own behavior IOC rules that you might see. So if you have seen some observation, you have seen some malicious activity, which you think that, hey, I think this is a malicious and suspicious behavior which I've seen somewhere, and there is no rule. So Palo Alto gives you approximately more than 250 such rules out of the box in the Cortex XDR application, but you can also create your own customized BIOC rules in the Cortex XDR application. So this is a very, very small comparison. Typically, manually, which all vendors do, is having some IOC compromise, IOC indicators of compromise, signatures, and stuff like that. BIOC is something which can, it's like this is somebody which is name of Arinjay. He's a bad person. That's IOC. But somebody who looks like Arinjay, has got a gun in his pocket, knife in his pocket, wearing a hat and a jacket and some advanced tools which are hidden inside the jacket, that's a behavior. And trying to open up a fire when reached to certain stage, that is in that case, I really don't care whether it is Arinjay or it is someone else. It says that the behavior of this particular person is bad and I want to stop it right there. With the help of BTP and BIOC, we can really stop all the attacks and automatically really detects different kind of behavior. So another small example is that we profile, and this is a module which is inbuilt in the Cortex XDR application, where we see that there is Windows PC, who is a standard user, IT administrator, AD server, Apple iPhone, etc., etc., right? And then we really profile those behaviors depending on the activities that they are doing over a period of time. So a Windows PC maybe daily transfer 3 TB data a day. In future, if it transfers 5 TB, then there is going to be an alarm by Cortex saying that I never seen this behavior. Maybe an IT administrator which always connects to database server or an AD server. Sometimes we see a ping or traceroute or netstat or some kind of a genuine tool usage in order to communicate that, and that's an suspicious activity. And by detecting and carefully profiling the behavior of the devices, users, and groups over a period of time, we can really see and detect a lot of malicious activity which otherwise seems very, very genuine, right? So it's a very small example, and I'll quickly run through that in the interest of time, because I have to also spend last 15-20 minutes for the demonstration, but we can collect different IP address application from the network logs, from the user agents, from the application logs coming from the Palo Alto Networks firewall, from the agents which are hosted, which are deployed on the endpoints. It can be the endpoint can be a Windows machine, it can be Windows server, it can be Linux server, or it can be also Mac OS, right? And we really, Cortex XDR, we really take. If you see this, really want to do this today, you need to have at least 3 to 4 tools, 3 to 4 dashboards, and a very, very strong team of understanding all different layers and know how to correlate this data and make sense of it, right? So Cortex XDR really bridged that gap and really try to make sense of how the attack has happened. In this example, you see a Chrome browser was used to download an exe file types, and that was actually opened the command prompt, which actually opened a PowerShell and then run a script, which is wscript, in order to attempt to connect to command and control example, right? And then the final use case is, instead of having different tools which I have tried to map it, you on the left hand side you see data coming from endpoint, network traffic analysis, firewalls, and UVA solutions, and then match it with the threat intel platform that you use. You need a lot of things, in the which is happening in the middle, right? On the right hand side, once you have the Cortex XDR application, a lot of these endpoint, NTA, threat intel, UEBA, and next generation firewall data is automatically correlated for you, and then it gives you a nice chain of events called as causality view. And then based on that, you can really do a lot of response very, very quickly. You can completely isolate the host from the endpoint, from the network, directly from the Cortex application. You don't need to go to the endpoint. You can maybe do a lot of queries, additional queries, which I'll show in the demonstration, in order to do more analysis or collect more forensic data, or really wish to see that what's really happening in the endpoint. Block the network traffic by directly integrating Cortex XDR and a Palo Alto Networks firewall, right? By using our external dynamic list, you can use a live terminal where you can do a live coordination with the compromised host and try to collect more data, and completely automate by use of SOAR platform, which is another acquisition that we did a year back, which is called as Demisto, is now rebranded as Cortex XOR. So you get a lot of power and lot of response tools right in that Cortex application, right? So I will skip this one in order to just show you the demonstration, and I will straight away go to the one of the main point on the POC part, where once we do the demonstration, I'm sure Runa will talk about will run through this, and whoever is ready to and wants to observe and really experience this tool can do a free POC. You can get in touch with Simon team, or you can also get in touch with me. I'll share my coordinates, or there is a hands-on workshop which I think Runa will type in the chat, and click on this link and you can see different languages the workshop is delivered to. It's a live workshop where you can actually get a good taste drive. It's like a taste drive and hands-on experience on how we stitch together the network, cloud, and endpoint data, how we stitch not only Palo Alto Networks data, but also coming from the third-party resources like Checkpoint, Cisco, and Fortinets. Really gives you a nice experience of, whatever I'm saying really works in the live environment, right? So let's quickly go to the demo part. I will have to share my screen. Runa, just a quick feedback. Can you see the screen?
Yes, we can.
Okay. So here is the dashboard, but before I go to the dashboard, I have used a real ransomware, which is called as Tesla script. That ransomware has been shut down now, but why I use this ransomware is because, Runa, you can see your Windows screen, right?
Yes, Arinjay, we can.
Right. So in the interest of time, I have already executed this ransomware. This is there on the dashboard on the desktop here. But this is not the sample. The sample actually got deleted itself, which I had executed. If you see here, just before this, I actually ran this file, and these are chain of events. If you see Tesla script copy file, and it executed additional file over a period of time, which has been actually already collected. And if you see here, this has been maliciously activity. This malicious activity has been stopped by the Cortex XDR application. But this is not the only thing. And if you see here, the component that is used is anti-ransomware protection, right? But it can actually stop that attack at each and every stage that you see here, right? Now, the reason why I have let these different stages go through successfully is by simply keeping all the different profiles in the alert mode, because I wanted to capture that activity. But if you see here, I will just show you the profile which I have used. I see, if you see here, all the exploit I have said as browser exploit, logical exploit, known vulnerabilities, all I have kept on report because I wanted to capture the activity. And at the very last, I have said only the one which is in the protection mode is malicious child protection, which is in the ransomware protection, which is in the block mode. The only reason, as I said, is I want to capture the entire activity and show it to you. But in the production environment, all this reporting will be blocked so that we can block that this particular attack at each and every stage, right? So if you see here, actually this ransomware has done a lot of activity which we have only reported by, and the mode is notified. But in case if there is only a hash control kind of a solution or an solution, and if the hash is known, it will only give you one single event, which is this, which is it is blocked by looking at the hash value. But a solution like Cortex XDR, which actually analyzes a lot of data and a lot of behavior-based analysis, you can get to see a lot of things, right? So going back to the dashboard here, it's a nice dashboard which can give you an open incident by severity. The dark red indicates high alerts, medium alerts is indicated in the different colors, and low alerts in different colors, right? You can also turn it in the light mode or dark mode. I personally like a dark mode. It's a new thing today. Everywhere we see dark mode. So you get open incident, you get incident by assignee, you get total incidents over a period of time, you get a top incidents here which are high. You can filter that based on high, medium alerts, and you get top post also. This is a simple dashboard that is created, which is called as incident management dashboard. You can have agent management dashboard where somebody who is assigned in, let's say there is a team member who is responsible for managing various and different agents inside the organization. So you can give access to only an agent management dashboard, which only says how many are disconnected, how many are connected, how many of them are Windows, Linux, and Android systems, what are kind of different agent versions are running, and so on, right from the dashboard. And with the top post, which has got a maximum high and critical alerts inside that. You can also have an incident management dashboard that we saw, and a security management dashboard. Somebody who is a manager and wants to look at everything here can look at the open incident, top incidents, agents, and different incident by assignee as well. Somebody who's like a SOC manager kind of a person now. But there can be a way that you can create your own dashboard also. So if you want to create your own customized dashboard where you want to be very specific in terms of what information you want to look at when you really I want to give a name here, test, and a blank dashboard, and said you want to be very specific in terms of finding out the information very quickly when you log into the dashboard, right? So you can just drag and drop of these things that you want. I'm just giving this one example. Detection by actions. You want to look at top incidents, and just drag and drop and just click and save, and boom, you will be having your own customized dashboard and a specific information that you want to look at when you log into the dashboard every day in the morning when you come to the office, right? So that's a quick dashboard. You can have your reportings and report templates. You can also similarly create your own report templates. But going to the main part, here is what the ransomware, what I've executed, which is Tesla script ransomware on the Windows machine here. Here is our incident, right? So this is my machine, which is a test machine, Acme Arinjay, which I executed just half an hour before we started our session. And here is the description of that, right? And you see a lot of data here. You see what is the host, you see what is the status, you see the alert breakdown in terms of how many are high and low and medium alerts. You see different resources. So if there is a resource from an agent, so here you see two resources. One is an inbuilt XDR BIOC that we discussed in the slides, and then also some data coming from endpoints. If there is a data which is automatically stitched from a network data, which is Palo Alto firewall or maybe checkpoint or any third-party resources, it will also appear here, and that can actually give you a very quick view of what amount of data, what kind of activity might have done by this particular example, by this particular ransomware, right? So I have already opened that incident. So if you right click on that and view incident, you will get to the screen. Now this is the incident ID. So you get an incident ID here. You can also change the name something to something that you want to know. So if you click on edit here, you can actually change script ransomware attack found, something like that. Something can make sense of it, and then assign it to assign it to. So currently this is not assigned. I can simply assign it to someone by saying that this is the Tesla script ransomware as a name. Do additional investigation and analysis based on that. Cortex XDR has already prevented it, but there can be additional alerts. So I see there are 12 number of alerts here. Before that, if you see here, we are going to show you all the key artifacts which are associated with this. Now, this is a file, this is the hash, this is the description of that. Remember, there is no signature. So that gives you a clear-cut view that, hey, there is no signature of this particular file. That is definitely suspicious. This is a wildfire threat intelligence, which is automatically given, saying that wildfire already knows this as a wildfire is Palo Alto Networks threat intel platform, right? Gives you that wildfire tells me this is malicious sample. If you want to see why wildfire is indicating this as a malicious sample, I can just quickly click on the analysis report and it gives me a complete 50, 60 odd page report in order to give you a very, very detailed information why this malicious what activity has done, right? But at the same time, you also can have a third party data, which is Virus Total or Autofocus, which is our threat intelligence platform, and gives you their different tags which are associated. So it's a Tesla script tag, read volume snapshot tag, etc., etc. On the right hand side, you see key assets. So that means if there are two machines, it will show you two machines. If there are any more additional machines which are infected and this ransomware has been executed, those machines will be also listed down here. So right from this incident, again, this is an incident. This is not an alert. You see all the alerts here. You see alerts here. So what Cortex XDR has done is taken all the alerts over a period of time, which has happened over a period of time, stitch it together and give you one single incident. So there are 12 number of alerts. 4 number of them are very, very low alerts. 12 are high and medium alerts, automatically stitched together from the Cortex XDR agent, automatically action taken. The names are also populated here and gives you a complete view of one single incident. So somebody otherwise would have done investigation and analysis of 12 and plus 4 different alerts from different sources. Imagine the amount of time that would have taken, right? And this is just 12. There can be very, very sophisticated attacks which can actually go to 200, 300 different alerts, right? How do you really stitch it together, So you get not just only one file, but you get different other activity which are done here. And once you click on this and anywhere on click on analysis, you get this nice causality view, and it actually gives you a proper view of how the attack has taken place over a period of time. So this is a Tesla script ransomware, which has happened, which has got 9 different alerts. This is the hash value, and if I just quickly run through these different alerts, it will keep on going into multiple different sets, multiple different areas. One of the area which I always try to identify is that this Tesla script ransomware actually did a lot of. So I'll click on this, and if you see here, it opened another process, it modified the Windows registry, modified proxy setting, it did fired some behavioral rule, etc., right? It also at the end of the day, it also really tried to delete. So once the ransomware is successful, it also tried to use a VSS admin. VSS admin, many of you might have known that it's a default genuine Windows inbuilt tool which delete snapshots or take the snapshot, right? To take the snapshot. But there are additional commands which are associated with this, saying that delete, shadow, all, quiet. Now this is the most powerful and mainly used a command which is executed from command line. If you see here from a system32 folder, it says that once the ransomware is done, once I have encrypted, attacker can resume its old snapshot of the file, and then the ransomware is not successful. But why? Because the user is able to restore the older snapshot, which is automatically created by Windows 10. So here I'm going to delete all the shadow, and this is the behavior which is captured. Now, if you look at VSS admin, nobody can see that, hey, this is the genuine Windows tool which is comes inbuilt. But if you see how this has taken place over a period of time, it gives you a nice view that this is definitely malicious. This is definitely malicious, right? And then I can do a further investigation on that, saying that that this is the hash value. I've already queried that. So if I go into query builder, I'll show you a query builder and say, is this the only machine? I can say that I want to see if there are any more machines which are associated or may have seen this impact. I can simply go into the file query and then just type this particular hash value. I've already done that in the interest of saving time. And I have got to know that this is one machine, or maybe there are additional machines which are associated with this particular attack. And I can simply isolate the endpoint. So I can show you that rightly from here. I can either completely isolate the endpoint. I can completely isolate the endpoint, or I can also do a live terminal. So by clicking on the live terminal, I can actually do a lot of analysis that I just talked about in the slides, right? So this gives me an ability to do a live terminal to connect to the actual endpoint machine and see what connectivity is happening. I think my internet is a little slow, so it's taking a little time. So I'll skip this, but I can actually do a live terminal in order to see what activity. And one of the activity which I can immediately find out here is this ransomware has executed one is created one more copy with some other name. See here, you see live terminal is active. There's a notification also given. You see this is the same name, right? And then also created one more file, then created one more exe, and then tried to do delete the snapshot of the file. No, it really makes a lot of sense of that, and then you can really see what's really happening. I think I have spent enough time on the demonstration. There are a lot of things. POC, we can really see all these things happening in your environment, and really gives you a real value in terms of what's really happening inside network, and see a real Cortex XDR value proposition, right? So thank you for this. Any questions? And I think Runa, we are going to take the question.
Sure, thank you. Thank you so much, Arinjay, for a very engaging session, and the demo, I'm sure, was very helpful to all of our participants. If you could just stop sharing your content.
Yeah, sure, I'm just doing that.
Yeah. So thank you, Arinjay, once again, and we are good to take the questions. Arinjay, would you want to read up the questions? There were a few questions that were sent in the group, and there were a few questions that were sent to me privately. So if you want to take,
yeah, I think I have also received a few questions directly.
Okay.
Okay, I'll quickly start. Quickly start with the question.
So there was a question from Rinal, but I think he had to drop out because he had some other meeting that he had to attend to. We can answer.
Yeah, so I'll read out the question. Can it integrate with AWS security? And we can definitely respond to Nihal private on a separate email. Can it integrate with AWS Security Hub as a security findings provider? Also, does it support AWS private link so that agents can talk to the platform privately? Now this is an endpoint solution. This can be installed in AWS workloads. It can be installed Azure, Google private workloads everywhere, right? And then you can also. I'm sorry. Is someone trying to say something?
Yeah, Arinjay, sorry, I have to move to a meeting, so I just wanted to ask that question. Since it is an agent, and since the agent cannot be deployed on IoT and edge devices because of the low transactability on this, how do you counter this, and how do you provide your coverage to IoT and edge devices? And that exactly was my question.
All right, so fine. So that's a good question. I'll answer it two ways. One of the way is our inbuilt UEBA and NTA. So we really do not depend on only the agent-based data. As I talked about, there is an NTA engine which is running inbuilt in the Cortex XDR. So we can find a lot of data from the network. So although it is an IoT devices and connected to the network, it may be generating some data. It may be generating some traffic, right? So we can really look at these traffic logs coming from either from Palo Alto Networks firewalls or from any third-party firewalls, as we discussed, right? But at the same time, we have something called as Pathfinder, which is a virtual machine which is running inside your network, and we can use this Pathfinder in order to probe the endpoint data. So that means if you cannot install an agent on the machine on an endpoint, we can use a Pathfinder virtual machine hosted there in that premise, in that location, which continuously probe the endpoint, and this probing will only be triggered whenever we see something very, very suspicious going on from the network traffic analysis, right? So we can definitely solve that use case by having a combination of Cortex XDR application, not by agent, application running in the cloud, which is having a network traffic analysis log inbuilt inside the Cortex XDR, and the Pathfinder virtual machine used to probe that that particular endpoint. Does that answer your question? And then we can discuss in detail. If you have a specific use cases, we can definitely get in touch with you and discuss in detail. Right.
I'll get back through Runa. Thank you very much.
What's your name, sir?
Yeah. Could you tell us your name, sir?
Okay, right. So other question is, does it support AWS private link or so that agents can talk to the platform?
Hello, Mrinna. Arinjay, we lost you.
Hello, can you hear me now?
Yes, we can.
All right. So can it integrate with the AWS Security Hub? I think Nihal is actually talking about different solution, but AWS Security Hub and all those are different type of API based solutions which monitors different APIs running in AWS or different cloud platforms. What we are talking about here is a completely endpoint and a network solution here, NTA solution, where we can correlate the logs on the endpoint. So it's like an endpoint, more on an endpoint solution that we do. Can it talk to support AWS privately? You need to have a connection to the cloud, to the Cortex XDR application, either directly or via a broker service that I talked about, right? So if you are able to give that either by AWS private link or by any other means, it doesn't matter how it is connected, right? I have got one more question. Is that I think we discussed about that, but I'll ask the question. Is that I have seen solutions from other vendors who talk about EDR a lot, but understood that XDR really gives me will give a nice view on network as well as endpoint data. Thanks for that. Oh, that's a comment. Okay, thanks for that comment. Yeah, one more question is that I have users, offline users who do not connect. I just answer that through a broker service, and we can show that in the POC. So if you have any group of users, some not connected to the internet directly, we can. I did a POC recently with one of the BPO where there are agents on one of the few locations are not connected directly, where we can deploy broker service, and you can use as many broker service as you want. There is no limitation. There is no additional charges on using a broker service. It's part of the solution. So in the POC, we actually deployed 5 broker services at 5 locations, and one broker service can manage up to 10,000 endpoints. So that's not a challenge at all in terms of scaling up from the endpoint and broker service perspective, right? I have one more question here. I think that's the last question. Is that what is the requirement? What is the prerequisite in order to start the POC? It's very simple. Entire cloud XDR application resides on the cloud. You don't need to worry about that. It's a tenant which is automatically created, and all you need to help me is deploy the agents on the endpoints. You can identify certain Windows and Mac or Linux endpoints, whichever are in your network, and then we can deploy the agent directly or manually or automated way if you have certain SCCM or some kind of automation tools, and all the machines will automatically connect to the Cortex XDR application. So all the tenant formation, Cortex XDR policies, everything is by default available in the cloud-based applications. You don't need to worry about anything deployed on-prem. It's completely cloud-based service, no disruption on the services, no downtime, no requirement of the heavy servers on your endpoint. So it's pretty simple. I know we actually initiated one of the POC in less than 2 hours and completely onboarded more than 50 endpoints for one of the customer in less than 2 hours. In less than 2 hours, we actually onboarded the entire POC for one of the customer very recently. So that's pretty simple and easy to use. I have one comment on the demonstration. On the workshop, yeah, is that how can we access the workshop? Workshop will actually give you a kind of a test drive to really see how the log stitching is done. I cannot show that in the demonstration because I don't have a checkpoint or potential firewall, but in the workshop you also will get to see a checkpoint and how we can stitch together different third-party logs also. So I think the link has already been given by Runa on the virtual workshop you see here. Just click on that link and you will see various various slabs available. You can see EMEA, you can see APAC. You can just select APAC. If you're in India, you can select APAC, and there are sessions happening next week. I think second week of July. Just register for that, and you will get all information on you can access the workshop. There is a predefined guide, and actually you will be doing whatever I just showcased in the demonstration, that you will be doing on your own by following a workshop guide. So you get actual hands-on work experience on how these really solution works, at least the critical and important parts of it. I think that's all questions from my side, Runa. Anything from your side?
No, I think for the interest of time, Arinjay, what we'll do is we'll stop here, and there are a few questions which we will take up on a one-on-one basis over phone or chat. So thank
right.
you, everybody. Yeah.
Thank you, everyone.
Thank you. Yeah. Thank you, everyone, for taking the time out of your schedules and joining us here for the webinar today. I hope the session was really helpful to all of you. As Arinjay had mentioned, we have a POC that we are doing especially as a complimentary service to all the attendees of this webinar. Our team will be getting in touch with you through the feedback form or through our consultants. You can just express your interest, and we'll get in touch with you to execute the POC or your interest for the virtual workshop that Arinjay mentioned. Thanks once again. I have pinned the feedback form in the chat window. Request everyone to just spend 2 minutes and give the feedback that you have for the webinar. Thanks, Arinjay, once again. See you all.
Thank you, everyone, and have a good day.